Hey guys, welcome to another video. Today we're going to tackle two word problems about integration. And some of these questions require integration with substitution. Some of these questions just require normal integration. So in the first question, it says a projectile's acceleration is studied. At a certain interval, the projectile's acceleration can be represented by a of x is equal to 3x squared over the square root of 3x cubed, where x is strictly bigger than 0. Find v of x, the velocity function of the projectile. Now, before we start this question, you must know that position, velocity, and acceleration are related together in terms of integration and derivative. So, for example, the derivative of position is going to be velocity, and the derivative of velocity is going to be acceleration. Now, the integration of acceleration is going to be velocity, and the integration of velocity is going to be position. So in this question, I'm giving you acceleration and I want velocity, so you have to do this integration process. But maybe in another question, you might encounter, for example, the velocity function, and you would be required to get the position function, in which you're also going to use integration. So it's basically the same exact question, but they require different things. Now, we must do the integration of a of x dx. So the integration of 3x squared over the cubic root of 3x cubed dx. Now, in this question, we must use integration with substitution, because I noticed that the power over here of x is to the power of 3, and in the numerator it's to the power of 2. So if I say let u be only the term inside of the radical, which is 3x cubed, so du, which is derivative of u, we're going to drop down the 3, which is going to be 9x squared dx. Now 9x squared dx closely resembles the numerator. However, in the numerator we have 3x squared dx. So what I'm going to do, I'm going to divide du by 3, and I'm going to divide this side by 3. So now I have du divided by 3, 9 divided by 3, it is going to be 3x squared dx. Now it perfectly matches the numerator. So the whole entire numerator is going to be replaced with du over 3, and the square root, inside of the square root, it's going to be replaced with u. So the integration is going to be, instead of 3x squared dx, I'm going to write du over 3 over the square root of u. Now, du over 3 is the same as 1 over 3 times du. So there's like, we can literally put in invisible 1 over here. So this will be like 1 over 3. So you can take the 1 over 3 outside. So it will be 1 over 3 over integration du over the square root of u. So now the integration for the square root of u, which is going to be u to the power of half. So 1 over 3 du over u to the power of half. You can take the u to the power of half up. So then it will become 1 over 3 integration u to the power of minus half du. And then apply the integration process. So minus half plus 1, it's going to be plus half over half. Now anything divided by half is the same as multiplying by 2. Or in other words, the number down can go up. So then it will be 2 u to the power of half over 3. And let's not forget the plus c. Now last step that you got to do, you just got to replace u back to 3x cubed. So it's going to be 2 square root 3x cubed over 3 plus c. And this is our velocity function. Very simple, as long as you know what you're doing, of course, and as long as you've mastered the integration with substitution. Remember, in order for you to pick correctly in the integration with substitution, like we're picking the choice of u, because it's very important for you to choose u correctly. You always need to look at the function in a way that if you chose u, just keep in mind that the derivative of this said u should be in the function itself. See, I knew that if I'm going to get the derivative of 3x cubed, I'm going to get 9x squared. And 9x squared is closely resembling 3x squared. So this is why I chose u as 3x cubed. Now, going on to the second question, we have this wonderful function in front of us. So it says the function above is symmetric with respect to the origin. So that means everything from over here is the same as everything over here. This is basically what it means because it's symmetric. So the function is f of x equals 6x5 over 3x6 plus 7. Find the area from -2 all the way till 2. So in this case over here, we gotta find the integration from -2 to 2, 6x5 over 3x6 plus 7 dx. But here's the thing, before we're gonna do this integration, stay with me a little bit. Isn't the integration from 0 to 2, so that means the area over here, isn't it the same as the integration from here to here? But like the only difference is one is on top of the x-axis and one is below the x-axis. So if you find the area of section 1, it's like you're finding the area of section 2 as well. It's literally the same number. The only difference is this, mathematically speaking, is going to be positive and this, mathematically speaking, is going to be negative. But since they said the word area, that means I'm going to take the positive value of it, of course, even if it's going to give me a negative value. Now, since section 1 and section 2, the area is going to be the same, why not change this integration to 2 times the area from 0 to 2? 6x5 over 3x6 plus 7 dx. See, instead of taking the integration from all the way over here, what I did, I'm going to take the integration only from 0 to 2 and multiply it by 2 because they are the same. Because it's symmetric with respect to the origin. So, I'm going to work on this second integration over here. Now, integration with substitution. Notice, x is to the power of 6. And the numerator, we got x to the power of 5. So obviously the derivative of something to the power of 6 is going to end up being to the power of 5, which means that u in this case, it's going to be 3x to the power of 6 plus 7. Du, it's going to be 18x to the power of 5, only dx, of course. Did I write dx in the beginning over here? Yes, I did. Okay. All right. So du is going to be 18x to the power of 5 dx. But here's the thing. In the numerator, I don't have 18x to the power of 5. I have 6x to the power of 5. So what I'm going to do is I'm going to divide du by 3, and I'm going to divide this by 3. Coincidentally, it's literally the same number that we're dividing by. So du over 3. 18 divided by 3 is going to be 6x5 dx. Now, the answer perfectly matches my numerator. So the integration is going to be 2 from 0 to 2. Instead of 6x5 dx, I'm going to replace it with du over 3. And the bottom one, I'm just going to replace it with the regular u, because over here there's no square root or anything, so it's just u. 1 over 3, take it out. So you're going to get 2 over 3, the integration from 0 to 2 du over u. Now du over u, as a rule, it's ln u. So 2 over 3 ln u between 2 and 0. Now, here's the thing. Before, you shouldn't replace u with 2 over here, because u doesn't have to do anything with the 2 and the 0. It's when you replace it back with 3x to the power of 6 plus 7, then you can substitute. So what we're going to do is basically 2 over 3 ln 3x to the power of 6 plus 7 between 2 and 0. Notice over here that I did not use plus c because I have bounds. I have from 0 to 2. So you shouldn't put plus c over here. So the answer is going to be 2 over 3 ln 3 2 to the power of 6 plus 7. And all of this is going to subtract 2 over 3 ln 3 0 to the power of 6 plus 7. Now, I don't have a calculator with me, to be honest, but if you put this on a calculator, you will get the answer really quickly. But let me just simplify it if I can. 2 to the power of 6, 2 times 2, 4, times 2, 8, times 2, 16, times 2, 32, times 2, 64. So it's going to be 3 times 64 plus 7 minus 2 over 3 ln 7. So 64 times 3, 192, plus 7, it's going to be 199. So 2 over 3 ln 199 minus 2 over 3 ln 7. And then you can get the rest. Alright guys, so this is it for today's video. Please like, please comment if you have any questions, and yeah, I'll see you on the next video. Thank you so much.